In this video, I'm going to be showing you how to calculate different questions related to electron shells, ions, cations, and anions. So the first question is oxygen has 8 electrons. What is the electron configuration? So we know that electrons live in what we call electron shells, and they basically resemble an onion. So the vegetable and onion, okay? In the fact that they have circular rings. So there are 4 shells that make up the shells of an atom, and we call them shell 1, 2, 3, and 4. Now the corresponding letter to each shell is K, L, M, and N. So within these 4 shells, and shell number 1 or also shell K is the innermost shell. So we have our nucleus there that's coloured in. So this would be shell number 1, and then we have shell number 2, then shell number 3, and finally shell number 4. So we work inside out. Now each 4 of these shells can hold a certain amount of electrons. So shell number 1, for example, can hold 2 electrons. Shell number 2, or also L, can hold 8 electrons. Okay, shell number 3, or M, can hold 18. And the last one, number 4, or also N, can hold 32. So 32 electrons. Now, we say that this is the maximum amount of electrons that each shell can hold, but generally what happens with shell number 3 is that it actually doesn't hold 18 electrons in there, and it usually only allows up until 8, and then it will eject the remaining of electrons to shell number 4. But these numbers in green show the maximum amount of electrons that can go inside each shell. So going back to our original question, oxygen O, which is the element symbol, has 8 electrons. Well, we need to see how we can distribute them to each of these shells. Now, we have 8 overall electrons. So we need to fit 2 into the first shell firstly. And that is because if shell number 1, or K, can hold 2 electrons, and the number of electrons that we're starting with from oxygen is obviously 8, we can fit the full amount of 2 in here because 8 is a bigger number than 2. We can take 2 electrons out of this and fit the maximum amount in shell number 1 because there are enough to put in there. So 2 of them are going to go in the first shell. Now, since we've taken 2 away, we are left with 6. So we move on to the second shell, which is L, and we see that it can hold a maximum of 8. Now, because we have 6 electrons we need to get rid of, well, actually all 6 can fit into shell number 2, or the L shell, because this can hold a maximum of 8, and we only have 6. So all 6 of those can go in the second shell. So the answer to the question is, the electron configuration is 2, 6. So these electrons can be split into 2 different shells. So question number B, draw the atom with its electrons clearly shown in their shells. So we're basically just drawing this. So I'll put the nucleus in the middle where the protons, which have a positive charge, and the neutrons that have no charge live. And I need 2 rings, so 2 shells. 1, 2. And I need to fit 2 electrons in the first shell. So I'll do 1, 2. And I need to fit 6 in the second. So 1, 2, 3, 4, 5, 6. Okay, so that is how we draw an oxygen atom. Okay, we've got 2 electrons in the first shell, 6 electrons in the second. None of the other shells are being taken up, so we draw it like this. Now moving on to the second question. Write whether each atom is a cation or an anion. So an anion is when an atom has either gained or lost electrons. Now, the next step after recognizing what an ion is to determine whether it's a cation or an anion. So cations is an ion that has lost its electrons, right? So cations are the ones that have lost their electrons. Now, if we think about the composition of an atom again, we've got the nucleus where the positive protons and the no charge neutrons live. And then we have the electrons that circle in the shells. Now, the electrons have a negative charge. And in a neutral atom, which I've mentioned before, we have the same number of protons and the same number of electrons. So that means that the atom is neutral because the positive charges and the negative charges balance each other out. There's not more of one than the other. They're balanced. But then when we look at a cation, that ion has lost electrons. It has lost some electrons here in the outer shells. So if it's lost electrons, that means that there are more protons now because we haven't lost any of those. We've only lost the electrons, and they're the ones with the negative charge. So now we have more protons than electrons, meaning that we have more of a positive charge because we have less of these negatives, which means the overall charge of a cation is positive because we've lost electrons. So now there are less negatives and more positives. So the overall is positive. It's the opposite for an anion. An anion is when we gain electrons. Okay, we've gained the electrons. So now that we have more electrons here in the outer shells, that means we have more negative charges. There are more electrons than protons, which means more negative charges compared to the positive charges. So now that we have more electrons, our overall charge is negative because electrons have a negative charge. Okay, so now we can go ahead and answer question 2. So the first one, this is the element symbol for silver, and silver can be found at number 47 on the periodic table. So its atomic number is 47. That means it has 47 protons and 47 electrons if it's neutral. So because we have a little plus sign up here, this shows that the overall charge of silver is positive because it's got a little plus sign here. So the overall charge is positive. And which one of these do we call a positive overall charge? Well, this one, the cation, because cations have lost their electrons. So now the overall charge is positive. So this must be a cation, right? It's got an overall positive charge because of this. So it is a cation. Now, because there are no numbers up there, that means that there is actually an imaginary 1. So it's just like maths when you have a pronumeral. So there is actually an imaginary 1 in front of that plus sign. So we can actually go one step further and say, yes, it's got an overall positive charge. Yes, it's a cation, but it has actually lost 1 of its electrons. okay, because there's an imaginary 1 up there. With this one, Zn stands for zinc. The atomic number of zinc is 30, so you can find that at number 30 on the periodic table. You'll see that zinc also has a little plus at the top. Now remember, this little plus means that the overall charge is positive. Which makes it a cation again, because cations have an overall positive charge. Now, because there's a little number 2 next to the positive sign, it means that this zinc has lost 2 electrons. So I'll just write here, lost 2 electrons. And lucky last, we have capital I. That stands for iodine, which has an atomic number of 53. So you can find it at 53 on the periodic table. And because we have a little minus sign up there, it means it has an overall negative charge. All right, and an overall negative charge means it's an anion. And again, because there's no number up there, there's an imaginary 1 lurking in front of it. So we can say that it has gained 1 electron. So what you need to look out for here is firstly know the difference between a cation and anion, which one's positive, which one's negative, which one's gained, which one's lost electrons. When you're looking at element symbols here, you need to have a look at what sign is up the top, and that will tell you the overall charge of the ion. Now, if there are no numbers next to it, there's an imaginary 1. If there are, that means that whatever that other number is how many electrons you have gained or lost. So I also forgot to say that here with iodine, which was an anion, anions actually change the last bit of their element's name. So yes, you'll find that in the periodic table it's called iodine, but because it's an anion and it has gained electrons, we actually now call the anion iodide. So we would now call this iodide, not iodine. Okay, generally you can conclude that metals form cations and non-metals form anions. So last 2 questions now, I'll just change my pieces of paper. Question 3, look at the following diagram. What's the electron configuration? Well, this is our element symbol, Ar. That stands for argon, or argon, however you want to pronounce it. And we can see that its mass number is 40 and its atomic number is 18. So this should be knowledge from the atomic and mass number work. So you should be able to look at this and read it yourself. So mass number 40, atomic number 18, and this is argon. Now, the atomic number is 18, which means that it has 18 protons and 18 electrons. So this is the number that we're interested in, 18 electrons. Now I'll just redraw my shells. So pink is how many are allowed in each. Okay, so we're starting with 18. 2 has to go in the first one. And now we've dropped from 18 to 16. So I have 16 left now. 8 can come out of this and go into the second one because this can take a maximum of 8. So 8 is our next number. And now we're losing 8 electrons from what we had, so we're down to 8 electrons. Then we move on to the third shell because the first 2 are fully occupied. Yep, 8 is less than 18, so all of those remaining 8 electrons must go into shell number 3. Okay, that's our electron configuration. Draw the atom with its electrons clearly shown in their shells. All right, so I'll do this here, I guess. Got my nucleus, and I need 1, 2, 3 shells this time. So 1, 2, 3, and I'll get my black pen. In the first shell, I have 2 electrons. So I've got 2. In the second, I've got 8. 1, 2, 3, 4, 5, 6, 7, 8. And in the third, I've also got 8 again. 1, 2, 3, 4, 5, 6, 7, 8. So this is argon. Okay, I've got my 1, 2, 3 shells, 1, 2, 3, nucleus in the middle, and this is how many electrons need to be in each shell, going from inside out. Now the second one, written a little bit different. This is exactly how you'd find it off the periodic table, the PDF version that I gave you. Look at the following diagram. What's the electron configuration? So now you should know that this is the atomic number and this is the mass. So the bigger number will be the mass number. So we're interested in our atomic number because the atomic number also means the number of protons, and if the atom is neutral, the protons equal the electrons. So there are 3 protons, which means there are 3 electrons. So I'll use my shells from up here so I don't have to redraw it. What's the electron configuration? Well, there are 3 electrons. 2 can be taken out of this and go into the first shell. That's its maximum. So 2 comma, and then we take 2 away from here, which gives us 1 left over, which means that 1 electron that's left has to go into the second shell. So our electron configuration is 2, 1. Draw the atom. Again, we need a nucleus in the middle, but this time we have 1, 2 shells. 1, 2. And black is going to show my electrons. All right. In shell number 1, we've got 2. 1, 2. And in the second shell, we've got 1. So 1.